Receptor mediated endocytosis is the primary mechanism in which cells can acquire macromolecules and other things that it needs from outside of the cell. And I must say, when I was looking at my textbook and I saw this diagram right here, it was a bit overwhelming. And one of my favorite things to do when I'm in terms of confusing diagrams like this is to maybe tangibilize it in a way in which I can understand. And the first thing that I thought of when I saw this diagram is a cookie. I mean, you can just see, you can kind of model a cell as a cookie. And today I'm going to show how I was able to learn this process by just using food, because I am a huge foodie, and what's better but than to learn cell biology using food, because you get to eat it after. So yeah. Alright, so this process begins with some ligands. So basically I use some toothpicks on the outside to kind of model those ligands. And what we're going to do is we're going to use some handy dandy Tic Tacs in order to just mimic those proteins that bind to the specific receptors. So in very first steps, it begins with receptor proteins coming along and basically binding to these ligands. And just imagine this being on each of these. These are going to create what we call a ligand receptor complex. And basically this is just going to go ahead and create a new chain of events that's just a little bit more exciting. So in the next step, we see a accumulation of these receptor ligand complexes and these little curvy things that we call coated pits. And these coated pits are really important because it's going to kind of show a lateral diffusion and kind of just get all of these receptor ligand complexes to come together, which leads us to our next step. So in the following step, we have an invagination of the membrane, and this is kind of facilitated by a couple of proteins, including adaptor proteins, clathrin, dynamin. And as a result, we're basically starting to create an internalized coated vesicle that's going to help lead eventually to vesicle formation. So the adaptor proteins, the clathrin, and the dynamin, like I talked about earlier, are all essential parts of helping this invagination form a full free-floating coated vesicle. And basically the three dots that I have up here are dynamin proteins. Those dynamin proteins are going to act as a belt. It's going to kind of help it pinch off into a fully coated vesicle. And the little dots that I have over here to the left just kind of represent the recycling of these coat proteins, because right after that it quickly loses its coat and it's now free to fuse with the early endosome and transport the vesicles to wherever they need to go. At the moment, the vesicle fuses with the early endosome. It has three different options of where it can go. In this first option, it can simply carry the material to a late endosome for digestion. This is just simply a pathway for materials the cell doesn't really need, so it simply just gets rid of it. In the second pathway, it's sort of a way for the receptors to be recycled. So simply it will take its material and it will float it all the way up to the top of the cell. And then what it does is it fuses with the plasma membrane. And this is a process which is super cool, in which the inner parts of the vesicle fuse with the membrane and the lumen of the vesicle becomes the outer portion of the plasma membrane. And that's also an explanation of how we get these ligand receptors in order to kind of repeat the process again. And in this third pathway, it's basically going to transport the material to the opposite side of the cell for transcytosis. So right here we can see an example of this material being carried through a transport vesicle to the opposite side of the membrane, and these materials are simply just carried to the opposite side of the cell because it's just simply passing through. For example, if you have an intestine, a lot of things like to pass through intestines. It's a common pathway for organs that just kind of have things that like to pass through them, epithelial surfaces and such. Although the cookie model is really oversimplified compared to the one that's in the textbook, I think it's really important to learn the fundamental ins and outs of a mechanism before you go into the little details, such as the specific coat proteins that are recycled and basically what the structures look like. And once you're able to get the movements down, then you can start putting in those infinite details. And I must say, this took me about maybe 5 minutes to create. And once I did the 5 minutes with the cookie, I was able to get this down in a matter of maybe 10-15 minutes. So this really helped me learn receptor mediated endocytosis. It was a mechanism that I used to stare at and thought it was super overwhelming, thinking, oh my goodness, how am I ever going to learn the 10 steps that go to that? To now I look at it and it's really no big deal. And who knew cell biology could be so delicious at the same time?